All right, good morning, everybody. Well, first of all, I thought I saw Michael here. There were so many URL encode moments that we have grown up with. Don't you agree? Okay, so what I'm going to do for the next 20 minutes is talk about a new compute that we released sometime last year. Again, this is an IBM Cloud. On IBM Cloud, there are many computes that we support. One of them is serverless function as a service. We are very proud of, and we are investing quite a bit in this. So I'm going to spend maybe 15, 20 minutes just to talk about, at a very high level, what this is and how you can quickly get started, and also the benefits that you see and some use cases we will talk. Of course, I won't be able to finish everything in the 20 minutes, so there is a large team outside in the IBM booth. Feel free to stop. There are advocates. There are code pattern experts that you can get some help from. So let me give an introduction. So let's say you had a brilliant idea to build a mobile app. It's going to change the world, right? So you plan to build a mobile app, and you also need to extract data from multiple sources. So which means you need a little bit of code that you want to write on the back end, somewhere on the cloud, somewhere on the server. And you're, let's say, a Swift developer, building iOS application, or it could be JavaScript for Angular. So you're just a front-end developer. You have no idea how backend is built. You have no idea what a hypervisor is, or what a Kubernetes container is, what a Docker is. All you know is a language, and you want to quickly build an application on the backend and get it up and running. You launch the app in the App Store. For the first 10 days, you have a few thousand people downloading and using it. The next thing you know, there are like 10 crore people downloading the application and using it. So you want to be able to scale the backend that you wrote, right? So without worrying much about scale out, scale in, and stuff like that. So that's what we call the new modern compute, which is serverless, function as a service. So we're going to quickly go through some of the concepts. So in a nutshell, what a serverless is, basically you have a piece of code, or you have a container, a Docker container, that you want to run only when needed, right? It doesn't have to be running all the time. If you have built a node application containerized, running on a cloud is basically consuming the CPU, and it's running all the time. So in serverless world, you just execute only your code, so which means you don't have to worry about the management infrastructure. You don't have to worry about the operations. You don't have to worry about do I need to keep it on all the time and stuff like that. You focus just on building the code, which is that's the value add that you plan to add. And like I said, the code that you run in the infrastructure should scale out transparently. You don't need to know. You don't need to know that there are 10 crore people downloading and using your backend. And the last one, being developers, coming from, let's say, a lot of startup companies, what pinches your pockets is the expense, right? It's the cloud or whatever is the hosting infrastructure cost. So you want to be able to, or you should be able to pay for the resources that you use, and not not pay for idling resources. So with that, let me just give one more example. What I have seen, I work with a fairly large utility company, architecting their end-to-end solution. What they have is a requirement where anytime there is reminders that they have to send, be it build due dates, it could be some reminders about outage and stuff like that, right? It's a utility company. They blast millions and millions of notifications, to all their consumers. So the way they had architected was, they have their own on-prem systems, everything running in a DB2 database. So they basically replicate the information that is required to send out the notification to cloud, right? Because they use cloud, they use IBM Cloud to send out those millions of notifications, using the push notification service. So they built a microservice, right? So there's a microservice that's a Node app, running with, maybe 3+ instances, so that, you get the maximum, high availability with running in 3 availability zones. And basically, the app keeps on polling, and the DB2 database replicates the data with, our Cloudant database, right? Cloudant is a CouchDB database on IBM Cloud. So they do the synchronization all the time, anytime there's a change, and the microservice is basically polling the database for a change, right? So it's polling the database for a change. As soon as it sees, something changes in the database, they pick up that and then send out those millions of notifications to their end consumers. So the problem, with this model is, you have a dedicated container, you have a dedicated cluster that you are running, and all it's doing is just polling the database to see if there is a notification that it has to send. Imagine, for a day, if they decide not to send any notification, I mean, that cluster is still waiting and looking for it. So in the serverless world, you set it up in a slightly different way, right? It starts with a trigger. Like, for example, in Cloudant database, you can actually set up a serverless, a function as a service trigger. So I'll cover that in detail in subsequent slides. So the trigger basically says, okay, I got something in my Cloudant database. Tell me, what do you want me to do? So the eventing infrastructure, what we have, with the IBM Cloud Functions, we'll talk about that in a minute, basically listens to these events coming in, and it just knows, okay, I need to compose this, and I need to blast off 1 million notifications to 1 million users, right? So that's a new way of compute. That's a new way of building applications. Some of you might have seen, from Lambda from Amazon. You do the same thing. So on IBM Cloud, so we have this infrastructure called as IBM Cloud Functions. So it is managed. It is managed. It comes with SLAs, guarantees, and stuff like that. And it's completely built on an open source technology called OpenWhisk. So OpenWhisk was the one that we built, and we collaborated with a few of other partners in the industry. And we built this technology, and then we put it out there as an open source. So, I mean, if you really want to stand up your own, you can clone, build, and run your own infrastructure, with your, on your own, or wherever you want to run it, on-prem or some other cloud. It's the same code that we run on IBM Cloud, and we run it as a managed service. So there are questions that usually I get. So does it mean that function as a service or a serverless, is that going to take over the world, right? I mean, will all of us be writing only code in serverless, and we're not going to go build any VMs anymore. We're not going to build microservices anymore and stuff like that. Well, the answer is no, right? Because there are different use cases. You need to apply different technologies for different use cases. Like, for example, if you look on the slide here, there are some folks out here who would be building core IT, so which means you will need bare metals, where you build up everything from ground up, right? So that you have to build from CPUs, what codes, how much code you want, how much memory you want, how many CPUs you want, and stuff like that. And I'm pretty sure, I think our partners, Rocket team also has built a lot of this infrastructure ground up. So that's one example. So as you go up the stack, if you go to the top, you lose control, but then you are abstracted away from the infrastructure. You just focus only on code. You don't worry about infrastructure. You don't worry about the scalability of that infrastructure and stuff like that. So let me just introduce you to the concepts. It's very simple. It's trigger, rule, and action, right? So there are triggers. So event sources, you can attach the trigger, so which is the top left. You attach a trigger to an event source, and then you execute a rule, and the rule in turn leads to an action. So action is where you write the code, whatever you want to do. Like the example that I gave about the utility company is, The trigger was the cloud and database update, and then the rule was, well, go build and run this action. And the action was, maybe 100 lines of Node JavaScript code, which was blasting out those millions of notifications, right? So it's triggered rules and action, which results, in the results. Now the action themselves, we support multiple languages. So if you're familiar with JavaScript, you can write JavaScript and run as actions. If you're familiar with Swift, you can write Swift, Java. So there's a bunch of languages that we support. The other thing that we also support is Docker containers. So for example, if there is a language that's not on this list, but there is a Docker image for that, you can just pull down the Docker container and then attach that as an action. So like for example, if you write in Go, get the container, run the Go container, and then attach an event, tie the trigger to that particular container execution. We do support different invocation models. It could be either synchronous, which is a blocking call, non-blocking call, or it could be set up as in a periodic way. There are many examples. Like for example, if you want to just put an API gateway in the front and a REST call, whenever there's an incoming call, to the REST API, that REST API, if you want to use that as a trigger and then map it to an action, which you want to write in JavaScript, you could use a blocking call, right? Because then you want to wait for the request to come back. But if you want to just trigger, an event and then, let the call, go and execute some business process, then you will use a non-blocking call for that. And finally, if there's a repeated way, like for example, the example that I use, every night, midnight, that you want to just collect all this information and keep all these things ready for next day morning, right? So that's a periodic event that you can configure. You could do many things. You could take one TRA, right? And then you can take the actions and you can chain them so that one after another, you just keep on cascading those actions, right? You could do that. The other thing you can also do is, parameter binding, which is, if you want to externalize, like username and password, right? So if you have a piece of code, you don't want to put username and passcodes, you can parameterize and then send them to the actions. There are multiple event sources that we deliver out of the box, but there's also the framework. If you use OpenWhisk with the open interface for event emitters framework, you can build your own emitters, and then you can attach it to OpenWhisk functions, which is the IBM Cloud Functions. So out of the box, you get one for Git, you have Slack, you have YouTube channels, you have push notifications. You can use many of these as your event sources, and then you can start building your triggers. Like for example, if you want to build a use case where anytime someone does a Git commit, or a Git push, that Git push will, eventually, kick off a piece of code which is an action, and in that action, if you want to notify the admin saying, hey, somebody did a Git commit, and if you want to kick off some build or something, right? So it's just 10 lines of code that you just spin up on IBM Functions and then attach it. So common use cases, if you want to use this for, let's say, you have a fairly complex microservice, you can use IBM Functions as a microservice backend itself. That's one use case. The classic use case is mobile apps. In mobile apps, you're doing heavy lifting on the app itself, but then if you want to remote some oftenly executed code on the server, you can remote this in IBM Functions, and then you can use that as your mobile backend. You can do many things, right? Like say there's a customer of us who basically takes a lot of these checks that come in, and they set up sequence of rules and actions. The rules and actions basically takes the check, does an OCR, then sends it to the next action. The next action does some recognition using the image recognition service, and then passes on the data to a cloud and database, right? So you can chain those actions. There are many IoT use cases. There's conversational bot type of use cases. You can use OpenWhisk or IBM Functions for those use cases. So here's a quick one. So I just want to introduce you to something called as IBM Code, if you've not heard. We are investing heavily in building these patterns on IBM Cloud. Would love to have some of you write your own patents and then you can publish. So these are best practices, capturing use cases, right? Whatever use case you are building, you convert that into a code pattern, and then you can put it out there on the pattern catalog. Like for example, this one, what it's doing is, let's say if you have an image, you have taken some photograph and then you have an image, and that image basically on the top left, you upload that into some backend. It's a Node or a Swift backend. The Swift backend takes that image and puts it in a cloud object storage, which is basically a blob storage on IBM Cloud. So you then fire off IBM Cloud Functions, which is the OpenWhisk rules. Basically takes it from cloud object storage and then runs it through IBM Visual Recognition Service. It extracts the text out of the image, and then it also sends it to the weather service, because now the photo itself has geolocation information. You take that and you send it out to weather service and say, okay, on this lat long, can you give me, what's the weather pattern, or what's the weather looks like and stuff like that. You take that and then using a push notification, you send it back to the user saying, hey, I just did the recognition. Here are the tags I see, and here was the weather information for that particular image, right? So you can do all kinds of cool use cases, by chaining these things. Another one is the one I just mentioned about image recognition. So which is you attach your trigger to cloud and database. Whenever someone syncs some data, uploads some data, or uploads an image, you get a trigger, and then you take the trigger, take the data, send it to different Watson services, right? You can do a lot of AI use cases. You can take the text, send it to NLP service. You can take an image, send it to image recognition service. You can, you take the audio, send it to, speech recognition service. You can do a lot of those chaining, and then, you can create innovative use cases. The biggest ones that we see, there are a lot of use cases around IoT, right? Because you can attach sensors, run a piece of code, and then act on those sensors, the data that's the events or the sensor events that are coming in. Okay, so that was a very quick introduction. I think I'm out of time. Very quick introduction to IBM Cloud Functions. So I certainly encourage all of you to visit IBM booth. Come take a look. Learn how it can be done. It takes not more than 5 minutes to set up and run your first OpenWhisk or Cloud Functions application. All right, thank you so much.